All right. So this will give you a count, right? This gives us a count. So we're trying to know how many departments are in the company. How many departments are in the company using aggregate function. And from what we've just seen, right, what happens? It gives us, we say select all from departments, right, which gives us 27 rows returned. But here we are adding a multiple row function, which is count here. So select count all from department, and that gives us what 27, right? So that answers the question, right? So if you say how many employees do we have in the company, a business case that says how many employees do we have in the company, right? How many employees do we have in the company, right? So what do? We can easily say select all, right, from employees, but this would not give us the total number of employees. It will just give us a list of all the details of all the employees in the company, right? But if we want to know exactly, and that says that 107 rows returned, right? So, but if we want to really answer the question there, we'll just select counts, right? Counts all from employees, right? That is what we have, right? And if we run this, to give us 107. Can you see 107 employees is what we have in the company, right? Awesome. That's what we have it right there, right? So to create a report of how many employees we have in the company, right? So we've answered that. Now, just doing a brief now. So if you want to know, generate a report of the staff who receives the least salary in the company, right? So you say select what minimum salary from what from employees, right? Select minimum salary from employees will give you the minimum salary of the minimum salary of employee, the minimum salary an employee earns in the company. Then you can now use that to get who exactly earns that work, that amount. So if we run this, this will give us the minimum salary, which is 2,100. Now, we now want to know who is that employee who earns this 2,100. So select all from employees where salary equals what 2,100, and it gives us that DJ Olsen, right, receives that salary. So we want to know who is the person who receives the maximum salary, the highest salary in the company. So what's the highest salary? 24,000. And who now receives that salary? So select all from employees where salary equals 24,000. And of course, we know that it is Stephen King who receives that salary. So basically, that is what aggregate functions are. If you look at it, they give us a single result per set of rows, right? It looks true. It does a passing through, a PARSING, a passing through of a set of data and gives us a single result for those set of data. So look at this, and I say generate a report of the lowest, the highest, average, and some salary, all sum of salaries in the company, right? Look at it. Select minimum salary as least, maximum salary as highest, average salary as average, some salary as total, right? From employees, right? So if we run all of this now, what you would have would be single result per set of row. Can you see? The least salary is 2,100, the highest salary is 2,400, average salary is 6,461.68, and the total salary is $691,400, right? So that is how aggregate functions work, right? Now we want to introduce what we call grouping. Grouping, right? So what that means is that we can do an aggregate. These aggregates that we have done is based on the total information on the table, on the employees table, right? But of course, we know that the employees table is divided into different departments. So how do we do an aggregation of these based on department? How do we make sure that the results or the analysis that we're doing, right? The query that we're sending to the database does not affect all the employees in the database, but only for a particular department. Then we introduce grouping, right? We introduce grouping, right? So it says grouping data in SQL. right? We use the group by clause to do that. We use the group by clause to do that. So now we are saying that we want to know for each department, not for every department now. I mean, not for the whole employees, I mean, the whole employees table, right? We just want to divide the employees, this result based on department. So we want to know the least salary in department accounting or department finance or department IT or department admin, right? We want to know the least, the maximum, the average, and the sum of salary for each of those departments. So how do we do that? Same statement that we wrote earlier. So we say select the department ID, the manager ID, right? Minimum salary, the maximum salary, the average salary, and the sum salary from employees grouped by what? Department ID. Can you see? This department ID, I mean, this group by, the group by function is where the grouping happens, right? So we are grouping by what? Department ID. That is, you're putting all the we are dividing the whole department table into segments by department, right? So using the department ID. So if you run this, what you will have is a result of 12 rows, right? 12 rows. Now, what does that mean? It means that we have 12 active departments in the company, 12 active departments in the company, 12 active departments in the company. Are you following me? Even though the earlier results told us that we have 27 departments, it means that we have 12 active departments and 15 non-active departments, right? That's what it means. That is, when we say active department, it means that departments that has people, right? So we have 15 departments that nobody there's no employee inside, right? So all the 107 departments, all the 107 employees that we have in the database or on the employee table are divided into 12 departments. And you can see that department 10, so there's a department that does not even have a department ID, whose manager ID is 149, whose minimum salary is 7,000, maximum salary is 7,000, average is 7,000, and sum is 7,000. What does that tell you? It means that this department only has one person inside of it, right? Then we have department 10, whose manager's ID is 101. Minimum salary is 4,400, maximum salary is 4,400. Average salary and some salary are also the same. So which means that this department as well, only one person is there, right? Then we have departments 20, right? Then we have departments 20, where we have the manager ID to be 100, minimum salary is 6,000, maximum salary is 13,000. Then we have average salary to be 9,500, and total salary to be what? To be $19,000, right? And you have it down like that for 13 different departments. I mean, 12 different departments. So this is a report of the aggregate function or the group function, group function, aggregate function, working based on what? Working based on what? On departments, segmentations of departments. Look at this business again. It says generate a report of the total number of employees in each department. So I just want to know in each of these departments, how many employees do you have there, right? How many employees do you have there? So you say select department ID, then count all from employees grouped by department ID. So in each department, we want to know how many employees we have there. So department 10, 1, department 20, 2, then this null department, we have 1, department 30, we have 6 people. Department 40, we have 1 person. Department 50, we have 45 people. Department 60, we have 5 people. Department 70, we have 1. Department 80, we have 34. 90, we have 3. 10, we have 6. Department 100, we have 6. Department 110, we have 2 persons, right? So you can see how aggregate functions work or group functions, how they work, right? Now look at this, right? It says generate a report of the minimum, maximum, average for each department in the company for all departments that has their average salary to be what? Above what? 5,000. So we want to see the same statement that we wrote up here to know the what? The sum salary and average salary and all of that for each department, right? We now want to know, we want to restrict. Remember that we use where clause in restriction. So we want to restrict to say that we only want to see, we only want to limit limit the rows returned to those departments that has an average salary that is above 5,000. That has an average salary that is above 5,000. That's what we want to look at. Average salary, right? Can you see? Of all departments that has their average salary to be above 5,000. To be above 5,000, right? This to restrict a select query that has a group by um, function, right? Or a group by, sorry, that has a group function and or a group by clause. That's a group by clause. So to restrict a select query that has a group by clause, right? The where clause cannot be used. Hence, we use what we call average, right? So what does that mean? It means that we want to restrict anytime, and I want to show you, anytime we use a group by clause, listen and listen to this. Anytime we use a group by clause, right, we cannot use where clause, right? So I cannot say where average salary is. Can you see? Immediately I did that. It mentioned that what my statement has an error, right? Because where cannot work in this situation. Can you see? The statement gave an error. Where clause cannot work in this situation. And what does that mean? It means that when you group people together, there's a common interest why you have grouped them together or that you have used to group them together. In this situation, we are grouping people based on their department. So we cannot say that this where this department has, right? It's a group of people, right? Even in English, right? You cannot use a singular noun. Is it singular noun? Singular verb, sorry, for a group of people, right? So what you do is what you use a plural verb, right? So in this situation, what we are doing is we're also doing that in SQL, right? So here we're saying that having a so where clause cannot work, right? So what we will say is that instead of using the where clause, we use having, right? We use having. So having is a what's it called? Having is the right clause to use in that situation. Having is the right clause to use in this situation. Can you see the error is gone, right? And if we run this now, you see that it will give us a result, right? So anytime, so I'm going to write that again. Anytime you use the group by clause, anytime, anytime the group by clause is used, group by clause is used in a select statement where having clause to be used to restrict results, right? Having clause should be used to restrict results. So look at this situation now. We're saying the select the department ID, manager ID, minimum salary, maximum salary, and average salary from employees. Group by what? Group by department ID. So the group by has showed up, therefore having follows, right? Group by department having a minimum salary that is what less than or greater than 5,000, right? So having comes to play. Having comes to play again here. Once you say a group by clause and you want to do a restriction, having comes to play. Right? So basically that is all that we discussed last class. So today we want to talk about joining. Joining. Hey, we want to talk about joining. Joining is a very important part of SQL. And I've told us before that joining is the last function of a select statement of the select statement. Remember, we've been using select statement to do a whole lot of stuff for a while now. Use select statement to do projection, We use select statement for selection as well, right? So today we want to see select statement in joining. And when we talk about joining, why do we join tables together? Right? We join tables together because sometimes what we need, right? What we need is not in just one table, right? If you look at it, we've been restricting data, we've been retrieving data from just one table at a time. Employees table, departments table, job history table, this table, that table, right? But there are some situations where what you need, right? What you need is in multiple tables, right? There are situations like that. What you need is in two or more tables, right? So when you want to retrieve data from those kind of situations, you have to join two or more tables together to be able to get your data out of that, right? Out of there. You need to join two or more tables together to be able to get your data out of it. And I want to show you how joining works, right? I want to show you how joining works today. I want to show you how joining works today, right? Joining is very interesting, although a whole lot of people have issues with it, right? But joining is very interesting, right? We would look at joining info. Let my mother whiteboard comes up. Come on now. All right, so this guy is up. All right, so joining is what we want to get into. So we're jumping right into it now. So joining, right? So joining is our way of combining or retrieving results from multiple tables, right? Joining helps us to retrieve results from multiple tables, right? It's as simple as that, right? We receive results from multiple tables. So take for example, right? Um, you want to know. So take for example, maybe we have a business case that says that um, retrieve retrieve uh, the um, retrieve the retrieve the full details of each employees in the company, right? So if we say retrieve the full details of each employee in the company, what does that mean, right? That would mean that we need to know everything about it, right? So, and of course, this comes from the employee table. So if we say everything should come from the employee table, right? Their name is from there, the employee ID is from them, their manager ID, the job ID, their salary, email, and all of that. But basically, what we have is that we only know that from the employees people, we only know that they have what we call a department ID, right? So even if employees Vivian is in department 10, right? Basically, what that means is that we can only quote that she's in department 10, but to a layman, we don't know what department state means. So, and that would negate, or that would not, that would mean that we're not answering the question, the full details of each employee in the company. So we need to retrieve, we need to get the name of the department, right? And the challenge is that the name of the department, right, does not reside, the name of the department does not reside inside the employee's table. The name of the department does not reside inside the employee's table, right? It resides inside the table called what, the department's table. So what that means is that for us to be able to get the full information, right, and basically to get the full information, we have to what, join the employee's table, right, and the department's table together, right? We have to join them together, right? So we retrieve what we need from both of them to be able to give us a corresponding table that has, this is employees table, this is departments table, right? But we have a table that this guy is coming from here. Maybe two columns are coming from here, one column is coming from here, and this guy would have three columns from both tables, right? Both tables are feeding this table. Are you following? Both tables are feeding tables, this table. So and note, this table is as a result of a join statement, right? So this table is created as a result of a join statement, right? So what does that mean? That means that the table in the actual sense does not exist. It's some sort of a pseudo table or a false table, right? The table does not exist. So for us to make the table exist, right? For us to make the table exist as a component of its own, right? We can either we can create it as a view. You can create the table as a view. That is, if you want to store the result of the join statement, you create it as what, as a view, right? And I'm going to show you what all of this means, right? Please let me know if you have questions as we proceed. Don't wait till a whole lot of information has been passed, right? Just follow me. It's a very interesting topic. You'll enjoy it as we proceed, right? You'll enjoy it as we proceed. All right. So back to our statement. So there are several types of joining, right? I'm going to go back to my. There are several types of joining. So I want to talk about types of joining now, or types of join. Sorry, types of join. We have what we call the inner join. We have what we call the outer join, right? We have inner join and we have the outer join. The inner join and the outer join. In the inner join, we have what we call the on, um, using the on clause. Hold on, give me a minute, please. All right, so we have the inner join. I'm back here. So we have the inner join, right? We have the inner join, then we have the outer join, right? When you're doing an inner join, we use the on or using clause. We use the on or using clause to perform an inner join. We use the on or using clause to perform an inner join, right? Don't worry, you would see them in action, right? Then we have on the outer join level, we have what we call the left and right outer join, right? So we have the left and right outer join. There's also what we call the self join, that is joining a table to itself, and a cross join, right? So these are basically all types of join that are available in SQL, right? All the types of joining that are available in SQL, and we're going to be looking at them one after the other, right? One after the other. We're going to be looking at them one after the other. So when we talk about, so we want to talk about the first one, right? We'll start with the first one, the inner join, the inner join. So when we talk about the inner join, what does that mean? Right? So when we talk about the inner join means that you are joining a table based on the criteria that the table, right? Based on the criteria that the tables that you are joining have something in common, right? So joining tables, multiple tables together, um, because they, or based on, not because, right? Based on the fact that they have common interests, right? They have common interests. Now, what are the common interests? Remember that we talked about constraints some time ago, right? Remember that we talked about constraints some time ago, and we talked about primary key and foreign key. So people who have issues with foreign key, this is a beautiful class for you to listen now, right? So primary keys and foreign keys. Now, these are the two constraints that we are really, really interested in now, and that we use in joining, right? So what that means is that for you to perform a joining, an inner join, right? You are joining two columns together. You're joining two tables, right? So we call this the employees table because this is the departments table, right? On the departments table, on the employees table, you have a column called the MID column, right? Which is a what? Which is a primary key. On the departments column, on the departments table, you have what we call the depth ID column, which is a primary key, right? But if you look at the structure of our employees table, we have a column on this part of this table that is called the depth ID as well. And what does that mean? I've told you that the department ID here was brought into this place, right? Such that it leads as a pointer back to this table. So here, that is a foreign key. I hope you're following me, right? That becomes what? A foreign key. So you have a primary key column here, right? That exists here as well, right? What does that mean? It means that if I want to join tables together, these two tables have a relationship that I can use to join them. I hope you're following me. These two tables have what? They have criteria or they have relationship that I can use what to join them, right? Because this column that is here is the same column that is here. That is, it has the same name. Now, what is common to them is that the two tables have a column. The two tables have a column that has One, same name. That is same column name. And same data type. Right? Once these two criteria is present, right, then we say that we can perform an inner what? Inner join. Right? First of all, what is necessary? What is necessary is that the two tables that you want to join together, right, there must be at least one column that they both share. Share in what sense? That is, they have a column, they both have a column that has the same name and the same data type. And to have the same name and same data type, right, what usually enforces that is that a primary key on one table is referenced on another table as a foreign key. In that situation, that gives us the premise of what we're looking for. I hope you're following me. In that situation, that gives us the premise of what we're looking for. In this situation, we have a department table and we have an employee table. We have on the department table a department ID column that is primary key. On the employee table, that column is now a foreign key table or a foreign key column, sorry, right? So which means that on both tables, right, you have what we call the department ID column. And because of the fact that they have the same name and the same data type, therefore they are qualified, that both of them are qualified for what we call an inner join, right? And because they qualify for an inner join, we can either use inner join them using the on clause or the using what? Using clause, right? Now, let me show you how that is done. Right. So it says inner join with using and on, right? So want to use using and want to use on, right? I'm sure that I've sent this code to us. We all have this code, so you can look it up and just follow, right? So it says create a report of employees and their locations and the location where they work from. That is what we want to do. Create a report of employees and the locations where they work from, right? That is what we want to look at. That's our first business case. Create a report of employees and the locations where they work from, right? So look at it. From that information, we want to go into our database to be able to understand where these informations are coming from, right? The information that we need is employees details and location details, right? So two things is either they all come from the same, all this information come from the same table, or they come from multiple tables, right? So if they are not in the same table, then we want to be able to look at it from all the tables that are available, right? And see how we can relate them together. So how do we do? Usually what we do is that you describe the first table, which is the employees table. If you describe the employees table, right, you will discover that you have all employees information there, right? Can you see? Of course, we're familiar with this table. We're too familiar with this table. So we have the employees ID, the first name, the last name, email address, phone number, dates, job ID, salary, commission percentage, manager ID, and department, right? So we have a table that contains almost all the information that we need, except that it does not have locations inside of it. Please follow me. It does not have locations inside of it, right? But we need the location of where the employees are working from. So, but from the details that we got from describing the employees table, we can see that there's another table that this column, which is a primary key column, is pointing to. So what do? We go and look for that table called the department table. So we describe that table as well. Now, department is telling us that, oh, okay, department gives us department name and manager ID and locations ID. So it does not tell us the location, but it points us to a direction of where we can get the locations. Because what that means is that if location ID is on this table, it means that there's a column where it is telling us more information, right? So what do? We check the database to see if there is a table called locations. So you look at it, you have employees, we have locations, and we have departments, right? So we describe the locations table, right? And we run that to describe the locations table, right? Now we can see that in the locations table, it is this location ID is a primary key of the locations table. Can you see? Then it gives us street address, postal code, city, state, province, and country ID, right? So we can now begin to join these tables together, right? Look at it. It says select employee ID. Now, I want you to pay attention to this statement, right? Select employee ID. Let me do this. Select employee ID, first name, last name, job ID, department ID, and what? Locations ID. Department ID and what? Locations ID. From employees table, join department what? Table. From employees table joins what? Department table. Now, the first clause that I want to look at is what? Is the using clause. Let me show you. Remember, we said we are doing an inner join. Using what? We're using the using clause. Why are we using the using clause? We want to know, do both tables have the same name and the same data type? So we go back to our statement to go and check, right? So if we go back to this statement here, employees table, if we run this, right? They both have a column called department ID. Can you see? Department underscore ID. We run department table as well, right? You see? Department ID. Can you see? So it means that they have the same what name and data type. The data type here is init. Can you see? Init. I said init. Int. It has integer. When we run this as well, let's check. Is it integer? Right. Department ID, integer. Can you see? Department ID, integer. So it means that then in that situation, they are qualified for what? For a inner join. They are qualified for an inner join. Both tables an inner join can work on both tables. So that way, we say select all of these from, and if you look at it, employees ID, first name, last name, job ID, department ID, right? The department ID, all of this, the first four are coming from the employees table. The department ID is common to both of them, so it can come from any one of them. And the locations table is coming from the department table, not the employees table, right? So we're saying from what? Employees, join what? Department. Using, now that's the key word that we're talking about. Using the inner join. Can you see? Using what? Using what is common to both of them. Remember I said that what? When you are using, these two must be present. Same name, same data type. So which column has the same name and same data type? So we're joining them using that what criteria, using the department ID column, right? Now, let me make this clearer. Joining is like marriage, right? Joining is like marriage. Of course, we're in a world where things are not normal anymore, right? But where people marry animals, people marry things, and all that, right? People marry somebody married a car, another person married a guitar, another person married an animal, but largely we see how people marrying people, right? Now, we're going to use Africa or Nigeria as an example, right? So consider an inner join, right? A situation where maybe you as a lady or you as a guy, you took maybe your spouse, you took your spouse home, or you're telling your parents about your spouse, and you're like, I know that those things do not really occur anymore. I'm not sure though, but you hear while you're growing up that you cannot marry somebody out of the tribe, right? So Yoruba parents will tell their children that you must marry a Yoruba person, right? Then the Igbo person will say you must marry an Igbo person, and Hausa will say you must marry an Hausa person. Although nowadays we have plenty inter-tribal marriage, right? Or the tribal marriage is happening, right? But let's just stick with the old school way of marriage. That is, you must marry from your tribe, right? Now, so when you take your spouse home, the question that they begin to ask your spouse is, what is your name? So it tells them their name is our name, Where are you from? Those are the questions that are most popular or most of utmost concern to your parents. Where are you from? Oh, maybe the guy is from, maybe the lady is from Osun State, and it brings a guy, and the guy is from Ogun State, right? Now, it can be even in the same tribe, right? There's ethnicity issues, right? So a Yoruba person will say that you are from Ogun State. Where in Ogun State? You say Ijebu. No, 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 no. I'm not. We don't want Ijebu people, right? But let's just leave that out. So you say, oh, you are from. So the lady is from Yoruba. She's Yoruba, or she's Igbo, or she's outside. Okay, let's use Igbo people, right? To say, I'm from Anambra. Oh, you're from Anambra, and maybe the lady is from Enugu. So, oh, awesome, awesome. We're both Igbos. We speak almost the same language. That's awesome, right? That is an inner join. They are joining them together based on the premise that they both come from the same area or from the same tribe. They are Igbos, or they both come from the same tribe. They are Yorubas. They both come from the same tribe. They are Hausas, right? In that way, it is easier, right? And why is it easier? The lady can cook the food from the tribe. The guy can eat the food from the tribe. They have the same language. They probably have almost the same history and heritage. They they are used to the environment. You know, a whole lot of things make it easier, right? If they want to marry, they don't have to do a whole lot of plenty ceremonies and all that. They understand the culture of each other, right? So when this one is saying that you have to bring so number of yams, he knows the reason why they are doing that. Do you understand? So it makes it easier, right? And that is the same thing that you have as in with inner join. So consider inner join as a join that is that that kind of intra-tribal marriage, right? That kind of intra-tribal marriage. And it's easy, right? Because for you to perform inner join, all you just need is that a column is shared between both of them, or a column is common to those tables or to the two tables, and this column has the same name and data type, right? That is as simple as that, right? So we are using now. We use using. Using is the keyword now, right? Of course, we're using joining to join the two tables together using what? On what premise, on what criteria that both of that this column is common to both of them. So if we run this now, you see that, can you see? This is a result of multiple words. It's a result that comes from two tables. Employees is coming from employee ID is coming from employees table. First name is coming from first employees table. Last name employees table. Job ID from employees table. Department ID can come from any one of them, and location ID is coming from the what? The department table. I follow me. That is coming from the department table, right? So we can write it like this, right? We can write it like this. We can write it like this. We can also write that same statement. We can also write the same statement, right? By saying select employee ID, first name, last name, department ID, locations ID from employees inner join. Can you see? We're specifying that it's an inner join now. Inner joins department using what? Department ID. The column must be in what? In parentheses, right? So if we run this, it gives us the same result. The same result. It gives us the same result. It gives us the same result. I hope you understand. Please let me know if you just understood. If you understood what I just explained. Hello.
I understand.
You understand, right?
Yeah.
Awesome. Lola, are you following us?
Yes, I am.
Awesome. Awesome. Good afternoon.
Good
Vivian,
evening.
good evening. Do you any question? Any question so far? All right. So I want to believe that we understood that, right? So we can we can join multiple tables together, right? This scenario is popular, and can join multiple tables together, right? Depending on, and that is why you need to understand the structure of your database, and that is why, remember, in the very beginning, the first assignment that I gave to us is that we create 5 schemas that are related to each other, such that you can retrieve data from multiple tables, not just from one table. And this is the reason why we do that. That's why we say that the data has to be the relations in the table, they have to be related to each other, such that they can complement each other, right? Such that they can complement each other, right? So now, if we want to even, so take for example in this scenario now, this department now, right? Department ID. We don't know the name of the department ID. What's department ID? So we can easily just say department. Sorry. Department underscore name, right? So I want to know the name of the department as well, not just the department ID only. So if I run this, right, can you see it fetches the name? So what that means is that employees ID, first name, last name, job ID are all coming from where? From the employees table. Now, department ID, like I said, can come from both of them, but of course, primarily it belongs to the department table. So department ID, department name, and location ID are all come from the what? From the department table, right? So you have a 7-column table that has the same what that has the same name and same data type, right? So now remember I told you that what this table, as it were, as beautiful as it is, right, is not a permanent object. Are you following me? It's not what? It is not a permanent object, because why? It is created based on a join statement. So to make it permanent, we say we create it as what? As a view. Now it says create a report of employees in locations 1,400 and store the output in a view, right? So what that means is that I'm going to now say, now look at it. I'm using, remember the view. Remember we said that a view is a database object that does not have its own data, but is dependent on the data from another table, right? That is a view is created based on data from a base table, right? So in this situation, we want to restrict what we've done here. Hold on, let me divide this now. Let me put departments, same statement that we just ran. Right, same statement that we just ran, except that we are restricting it to what? To departments. The business case says that employees in what? In locations 1,400 only, right? Don't worry, we'll understand what location 1,400 means later, right? So the same statement, select employee ID, first name, last name, job ID, department name, and location ID from what? From employees. In-house join department using what? Department ID, where locations ID equals what? 1,400. So if I, let me just run this, copy this, right? So that you see what we're talking about, right? So if I run this now, right? So this is what you have, right? This is what you are. This is what we have, right? This is what we have. We have just how many people? 5 people in that location. So which means that basically what they are saying, what this is saying, that everybody in the IT department is working from the same location, right? Everybody in the IT department are working from what? From the same location. So, but this table does not exist, right? It only exists because of this statement, right? It is not a permanent table. So to make it permanent, what do? We create it as a view. That is, we create this query and we store this query is stored inside a view. That's what we want to do. So how do we do that? We say create or replace view, right? And we give the view a name. So I'm going to give this view emp underscore loc underscore 1,400 underscore view. right? M in location 1,400. That's what we have. So if we run this now, it will tell me that a view has been created. Let's see. Right. So we say create or replace view. That is, well, what does create or replace mean? Create, remember, we want to create an object, we use create. So why is there a replace? Replace is saying that if the object already exists, right? If the object already exists, if the view already exists, replace it. If the view already exists, replace it. That's what you're saying. So create or replace view as what? As now, what is this doing? This is in this situation, we are able to what? We're able to create and populate the object at the same time. We created the table, which is a view, and we are populating it at the same time. We created the view, and what? And we are populating it at the same time. That's what we're trying to do, or that's what we're doing. But yeah, let's show this. Hold on, please. I'm just trying to retrieve my cursor from where it's hiding. All right. So create or replace view, right? Create or replace view. So if we run this view now, can you see? It says the view has been created, right? The view has been created. So now let us now query the view. Remember, the view is underscore loc underscore, right? So if I say select all from the view now, that is, we are now querying the view. Querying the view. So you can query your view, right? It is a table as well. Right? So if I query the view, can you see? Only what is stored inside the result of this select statement is stored inside of it. Are you following me? Only what is stored inside the select statement is stored inside of it. Right? Only what is stored inside the select statement is stored inside of the view. And that is how we create a view. So we use create or replace, then as what? As select all. So you remember, and I said that what? A view is used to what? Is used as the mode of what? Security. So which means that if I only want an employee to see just this part of my table, right? Just this part of my table, I write, or just a part of my table, I write a statement that retrieves that part and store it as what, and create it as what, as a view, and give that person what? I will just give that person privileges on that view, and that will be the only thing the person will be able to see, or the only table they'll be able to query. So that is how to create a view. Please let me know if you understood all I just said. Um, all right. Now, what? Yes, somebody wants to say something.
No, I just wanted to say I understand it, kind of. Yeah.
Okay. Talk to me. You want to understand?
No, I said I understand. I understand.
Oh, okay. Awesome. 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 All right. Now, we want to use joining, alias, using alias or joining tables with aliases, or using aliases in joining tables, right? Now, it says generate a report of employees in locations what? 1,400 and 1,500, and the salary of the employees in this location, right? Want to generate the people in this location and their salary, right? So question is this data coming from a single table or multiple tables. So we want to know, right? So of course you do all the rituals that I told you to do. You begin to describe each of those tables to be able to know the content inside of each of them and how to join them both together, right? So now if you look at it, this last one that we did, right? The location did not even give us full information about the location, right? It is still just giving us the location ID, right? I'm going to run a statement that would give us the full information about the location, right? So I don't want to jump the gun. I just want to take it one step at a time. Awesome. Awesome. We're even almost close to it, right? So now it says generate a report of employees in what? In locations 1,400 and 1,500 and their salary and the salary of the employees in this location. So what do we do? Now, look at it. I want to introduce aliases to you, right? So that you understand. So I'm just going to, hold on. Let me remove all of this so that you don't get scared. Right? Still the same statement that we ran earlier. Still the same statement that we ran earlier. Right? Let's put department ID again. I mean, right? So select employees ID, last name, salary, department ID, department name, locations from employees joins department, right? From employees join department, you can use inner join, that is if you're using an inner join, or don't worry. So just say joining, but of course you can use inner join in that situation if it is an inner join that you're doing. Using from employees join department using department ID, where location ID in, remember we are checking for two locations in 1,400 and 1,500, right? Now, the question is, how does the system know, or how does the database server know where these tables are coming from, right? Of course, by default, it knows, right? Because we are specified. So it just checks each of the tables and checks the corresponding columns that comes from them. But we can make it easier for both the system and even for we and any other person that is going to look at the query to be able to understand. And we can use aliases to qualify the table or the columns, right? To qualify the columns where they are coming from. So I'm going to start from the from clause. So I'm going to give this from clause, right? Employees. I'm going to call that employees. I'm going to space it and I'm going to put E. And I'm going to put a space and I'm going to say department is now what? D, right? So employees alias is E. Remember our alias from aliases. Employee alias is E and department alias is what? Is D. Now, what am I going to do with that? I'm going to say that, of course, the employee's ID is coming from the employees table. So I'm going to say E dot employees. Last name is coming from what? From the employees table. So I'm going to say E dot last name. Salary is also coming from the employees table. So I say E dot salary. Then department ID. Now I can specify where I want it to come from. So I can say, okay, come from D. I want the one from, remember I've said that it can come from both tables, right? So we're going to do this. I'm going to say,
Sorry, the E doesn't mean employee.
yes, it
The
means
E
the
that you're
employees.
putting.
Yes,
Okay.
yes. Yes, I'm going to say E dot department ID. I'm going to copy this. Copy. I'm going to paste it. And I'm going to say D dot department ID, right? And I'm going to say another D dot department name and D dot location ID, right? So what does that mean? I'm saying that this is employees table dot employees ID. Last name is coming from the employees table. That is last name of the employees table. Salary of the employees table. Department ID from the employees table. Department ID from the department table. Department name from the department table. And location ID from the department table. right? So if you run this, what you have is this. Can you see? That's what you have. What you have is what? Is this. It gives you that result. Right? So in this situation, what we have done is that we have used aliases to qualify. We've used aliases to qualify the tables that we're joining together. We use aliases to qualify the tables that we've joined together. Right? Now, it says generate a report of all employees, including full details of their location. Can you see? Including what? Full details of their location. So we didn't get the full details of their location before, but we'll need the full details of their location. Remember, most of the data is coming from the employees table, the departments table. But on the departments table, what we have is a pointer called the locations ID to the locations table. Right? So we want to join three tables together. And this is what I mean. In this situation, we have three tables. We want employees details. We want to retrieve employees details with full location details, right? We know that, of course, we have established that the employees table has some of this data, right? The department's information is coming from the department's what? Department's table, right? But this department's table has what? So joining these two tables together is what is the department ID, right? But this department table has what we call the locations ID, right? Which leads us to the locations table. So we have another table called the locations what? The locations table, right? Locations table. Now this table, right, is where the locations ID is what? Is primary key. But joining these two tables together, we know that what is common to both of them is what? Is the location ID, right? So what does that give us? That gives us, that gives us this scenario. That gives us this scenario that we are joining the employees table to the departments table using what? The department ID, right? We're joining these two tables together, and we're joining the departments table to the locations table using what? The location ID column, right? So which means that for us to be able to join three tables together, we have to join these two tables with what? With this column, and these two tables with this column. So this guy is in between both of them. Basically, what that means is that in ideal situation, this table and the locations table do not have anything in relations, right? Except that department is what is connecting both of them together. Eventually, what does that mean? In AR relationship, say every employee belongs to a department that has what? That is in a location. Every employee belongs to what? A department that is what is in a particular location, right? Or a location contains one or more departments which has what? Several employees, right? So that is how you connect both of them to what? Or the three tables together. So let's go back to the code to be able to see how to get that joining done, right? So now we have to qualify them, right? So look at it. So we have it's a long call, is a long one, right? So we have employees ID, first name, last name, job ID, department ID from the employees table, department ID from the department table. That's how we have them double. Department name, locations ID. Can you see locations ID? Locations ID again from both tables. Then we have the street ID, street address, postal code, city, province, and country ID. Right now, let's just calm down and take it one after the other. So we're going to start from the from clause. Remember, I said the employees, right? So we're qualifying the employee as E, that's the alias, joins department what? D, using, can you see? Using department ID. right? This guy, employees table joins departments table, right? Using department ID. Join locations, right? So if you want to make it a long query, it's actually supposed to be like this, right? So that you can see all in full, right? Employees E joins departments D using department ID, joins locations L using what? Locations ID. That is, employees table and departments table are joined together using what? The department ID. That is the rope that we use to join them together, right? And the departments table is now tied to what? To the locations table using a table, a column that is common to both of them, the locations ID. Both of them have a location ID column, right? Now, having understood that, we can now qualify each of the columns and where they are coming from. The employee ID is coming from the employees table, first name from the employees table, last name from the employees table, job ID from the employees table, department ID from the employees table. Then also the department ID is also coming from the department table, so that we can what? We can compare. Of course, they are the same, right? Then we have the department name is coming from the department table. We have the locations ID is coming from the department table. Then the location ID again is coming from the locations table, so that we can also compare, right? Then we have the street address coming from the locations table, the postal code coming from the locations table, city and province, state province coming from the locations table, as well as the country ID, right? As well as country ID. So if we run this statement, what you would get would be a full-blown report from 3 tables. Can you see? Full-blown report. So what does that mean? We're saying that Jennifer Whalen, who is employee 200, who is Jennifer Whalen, whose job ID is admin assistant is in department 10. Can you see? Both table has the same data. Department ID from the department table, employees table, and department ID from the department table, right? Who is in department 10, which is the administrative department, is the administrative department resides in locations 1,700, which street address is 2,400. 2004 Charlotte Road. Postal code is 98199, Seattle, Washington, US. Can you see? So you get a full-blown information, right? So this information is not just coming from one table, but how many tables? 3 good tables. 3 good tables. Right? So that's basically how to use the using clause. The using clause is easy. It's an inner join that requires that a column be common to 2 tables, such that this column has the same name and same data type. Therefore, it is used as what? As the rope or the criteria to tie these 2 tables together. Right? Then we want to look at the second part of the inner join, which is the on clause. Remember, I told that you can either use the using clause or the on clause to perform what? Inner join. Inner join is easy. It's the same process as um, using clause, except that it uses qualifiers or aliases to um, to specify where the tables are coming from, right? So, or the columns are coming from. So it says generate a report of employees and their locations where they work, right? Same scenario, right? Same scenario, except that we have to what? Start from the from clause and says we are qualifying the employees as E, right? Now the employees as E can be M, right? It can be um Lola, right? We can call it anything, right? We can call it anything, but the simplest way to qualify them so that you don't have to type too much is E, right? So we use employees E, joins departments D, such that we know that the employees ID is coming from the E, which is the employees table. Our first name is coming from E, which is the employees table. Last name from the employees table. Job ID from the employees table, department ID now from the department table, and location ID from the locations table, right? Right? From employees E joins department D. Now, how does the on clause work? Remember that for using, we say using, then in brackets, the department ID, that is the column that we're using to tie them. But in the on clause, this is how we specify the on clause. From employees E joins department D on E dot employee ID, E dot department ID is equals to D dot department ID. right? Right? So we're saying that the e.employee ID is equals to d.department ID. This is how this works, right? So if you run this now, it gives you the same result as it gave us earlier, right? Give us the same result as it gave us earlier, right? So the on clause, look at the on clause. The on clause is e.department ID equals d.department ID. That is how we use the on clause. It's different from the way we use using, right? Using is where department E, employees E joins department D using what? Using department ID, right? So I can break this down. So using department ID joins department L using what? Using locations ID, right? So that is different. Using is usually this way. It's usually named this way. This is the syntax for it, right? Usually this way, right? Using and the column in the column that is common to both tables in what? In parentheses. But for on, it's a bit different. On is that the e.department ID equals d dot what? Department ID. Basically, that is how that is done. So if you want to write this statement that we wrote earlier that answers generate a report of all employees including their full details, including the full details of their locations. If we're going to write it, um, this is how we wrote it for the what? For the using clause, right? So we're going to do the on clause of it, right? It will be a bit different, right? Same syntax, sorry, right? Same syntax. Now you say from employees E, right? Sorry. From employees E join departments D, right? On E dot department ID equals D dot department ID. Joins L on D dot location ID equals L dot location ID. Right? So that's basically how that is done. How that is basically how that is done. Right? So we want to talk about non-equi join, right? Non-equi join. Equi joins are okay. I forgot to mention that equi joins are all this joining that we've talked about. The inner joins are also known as equi join, right? Sorry, I forgot to mention that. Inner joins are also known as equi join, right? Inner joins are also known as equi joins, right? So this is an equi join, that is the values are equal, right? Equi join, that's what we call them, right? Equi join, and which means that the same name, same data type. That's basically what the equality there means. Equi join, equality join. That is, they have both same name, same data type. So for on and using, right? For you to use both on and using, right? The columns must have the same what? Same name and data type, right? Same name and data type, right? So having said that now, having said that, having said that, we want to go into non-equi join. Right? We want to talk about non-equi joins now. Right? Non-equi joins. Right? Which is also known as our outer what? Outer joint. Right? So it says now it says non-equi join is a kind of join that the equal to operator cannot be used, right? Basically, right? You'll just see what I mean. So let's look at it. It says generate a report of salaries of employees and their salary grade, right? We want to generate the report of salary of employees and their salary grade, right? So here we use an outer join, right? It says outer join is joining columns that are unmatched, right? Remember, the first join that we did, we said was they must have the same name and same data type, right? So to do an outer join, hold on, not equal join. Okay, I didn't answer this. Let me answer this, right? So, um, all right, sorry. Just give me a minute. Let me quickly run the statement. So it says generate a report of salaries of employees and their what? And their job grade table. So to do this, right, you want to first of all query the tables that are available, right? The tables that the data is coming from. So of course we know the employees table is one of that. So employees, right? Of course we describe this table we've described a couple of times, right? Then um also want to describe the job grade, right? Let me see. GBGB. Oh, no wonder. Um, no wonder. I remember that the reason why we're not able to solve this at that in my last cohort was because the salary grade table was not available, right? So I'm just going to remove this. So I'm going to look at another example that explains that out, right? So let's look at another example that we use to explain non-equal join, right? Right. So want to look at the outer joint, right? Now it says the outer joint is also the component of non-equal joint, right? And it says that um, where these are joining where the joining columns that are unmatched. You are joining columns that are unmatched, right? So take for example, what does that mean? It means that let me explain this before we move into this. So for the equal join, which is the inner join that we saw earlier, right? If you look at it, we said the two tables, the employees table and the departments table, must have a column called the department ID that has the same what? Same name and same what? Data type. If you look at the result, they both have the same name. So the ID table as the employees table has a column that its data is the same in the what? In this part of the table. This column is the same thing as this column, right? That is why they are inner what? Inner join. But for the outer join guys, right? For the outer join ones, right? What we are saying is that the column that we are joining together, right? The two tables for the outer join, right? The two tables have columns that are unmatched. That is, this table, we are joining this column, right? Let's join a few of those tables together, right? This table, we want to join this column and this column together, right? But this column and this column are not the same. That is, one of these columns have data that the other does not have. Are you following me? One of these columns have data that the other column does not have. Maybe this one has more data than this one. Maybe this one has more data than this one. So we'll call this one the table on the left. We'll call this one the table on the right. Right? This is the table on your left, and this is the table on what? On the right. So when you have now listen to this. When your table on the left has more data, when the table on the left has more data, we call it left outer join. We use left outer join. When the table on the right has more data, we call it what? Right outer what? Join. Are you following me? When the table on the left has more data, we call it what? Left outer join. When the table on the right has more data, we call it what? Right outer join. Right? Basically, it's as simple as that. Right? Right? And in Oracle, if we were doing Oracle, we can now merge both left and right outer join to form what we call a full outer join. A full outer join, but this does not work in MySQL, right? So we're not going to talk about this, right? We're not going to talk about this full outer join, but we'll talk about left outer join and right outer join. And why are we calling them outer join? Because why? The table on the left might have more data than the table on the right, or the table on the right might have more data than the table on the left. Now, than the table on the left. Now, notice they have the same data, just that one has more data than the other. That's basically what you're saying. One has more what? Data than the other. One table has more data than the other on the columns that you want to use to join them. So let us look at an example. Now it says generate a report of employees that are without a department. We want to see if there is an employee without a department in the company. Of course, maybe the company just recruited some employees, or maybe some employees have been on training for a while, or whatever the case is, or maybe some employees are on contract, whatever the case. There are some employees that didn't have a department. So we want to know them. We want to know the employees that are without the department. So what do we do? Of course, from employees E, let left outer join departments D, right? Employees on the left, department is on the right. So we want to see employees that are without a department. So which means that in this situation, the employees table has more data in that regard compared to the department table. That's what we're looking at, right? So it says select employees, first name from the employees table, last name from the employees table, job ID from the employees table, department name from the department table. From employees E, left outer joins departments D. On, now look at it, we're using on now. We're using on. Now look at it. Left outer. Are you there? Left outer. Now, one thing I also did not mention at the other time is that when you're using the on clause, right? When you're using the on clause is not as smooth in its workings as the using clause. The using clause is straightforward. It is a very swift inner join. Now, the on clause, let me liken it. Let me go back to the illustration of marriage that we have, right? So you are saying that Trisha wants to marry Abubakar, right? Trisha wants to marry Abubakar. Now, Trisha is an Igbo lady. Abubakar is an Hausa guy. Naturally, they are not supposed to get married because, come on, Igbos hardly marry Hausas and Hausas hardly marry Igbo. But these two fell in love in Canada and they want to marry each other, right? So Trisha has gone to speak to her own parents and say, hey, I love him. He's smart. He's the CEO of Google. He has 10 cars. He has blah, blah, blah. And Abubakar has gone on to tell his parents that, man, this lady is awesome. She works at Harvard. She's this, she's that. I'm in love with her. Tell the story. They have explained to their parents, right? Now, the parents are the ones with the rules. They're the ones with the constraints. So they are like, no. Okay. So they begin to, on their different paths, begin to consider it, if it is workable or not. So they're looking for a reason for that to work. They're looking for a reason. So the mother of Trisha is saying, it's not Igbo now. How will you be able to cook Hausa food? How will you be able to do this? Abubakar's mother is saying, she's not Igbo, she's not Hausa now. How will she understand our culture? How will she understand this and all of that? Then they all come to the conclusion that, well, at least is Nigerian from the Abubakar side. And from the Trisha side, they say, well, at least it's Nigerian, right? Now, what they have done is that it's like a permissive, a permissive, how do you call it now? A permissive condition, right? Or a very minute condition. Or we call that minute. They are using the last straw of option to join them together. That's basically what I'm trying to say, right? The only option left is that, well, as long as it's Nigerian, right? So the father is, are you sure this Abubakar is not from Israel? or it's not. I mean, it's not from Egypt or it's not from Algeria. No, you say it's Nigerian. Its father is even the this of this and that. Okay, no, well, as long as it's Nigerian, we agree. And that is why we are using e.department ID equals d.department ID. What we are literally saying with this e.department ID equals d.department ID is that, you see, the table name are the same, but not necessarily the data type, or not necessarily the content inside of it. The table name are the same, the data wise are the same, but the content might not be the same. That's basically what we're trying to say in that situation. That's what we're saying. So it's like you are doing a force, right? We're forcing them to. So that is why if you look at it, we first of all highlighted that it is a left outer join, and we are joining them on what department. The only straw that we can use to join them together in this situation is the department ID column. But of course, in this situation, department ID column is perfect, right? So in some situations, it might not be so perfect, right? And we are ordering by, of course, remember order by department, what department name. If you do not specify ascending or descending, by default it is ascending. So if we run this, you would see all the results of everybody, right? It says 107 rows returned. So who does not have a department? So Kimberly Grant is a sales rep without a department name. Can you see? Let's see if there's more. So basically, only Kimberly does not have a department name. Now, what does that mean? Only Kimberly does not have a department. So she's probably a sales rep contractor that does not really belong to the company, right? So, or she's doing rounds. Maybe she's learning from department to department. Maybe she's doing management training or something, right? So at that point, she's the only one without a department, right? So the next thing is we want to flip the coin, right? So she generates a report of all departments without an employee, right? We want to flip the coin now. We're flipping the coin now. We have seen department employees without a department. Now we want to see departments without an employee, right? It says generate a report of all departments without an employee. Same situation from employees E. This time around, the table to the right is what has more data, right? So we have right outer joins department D, right? On E dot department ID equals D dot department ID, order by job ID, right? Now we're saying that employees, first name is from the employees table, last name is from the employees table, job ID is from the employees table, department name is from the department table, right? So if we run this now, what we got? What do we have? This is what we have. Now look at it. We have plenty first name, last name, job ID that are empty, right? Can you see? Plenty first. How many rows returned? 122 rows returned, right? But we have treasury. Nobody is there. Can you see? First name, last name, no. Job ID, no. Corporate tax, nobody. Control and credit, nobody. Shareholder service, nobody. Benefits, nobody. Manufacturing, nobody. Construction, nobody. Contracting, nobody. Operations, nobody. IT support, nobody. NOC, nobody. IT help desk, nobody. Sales, government sales, nobody. Retail sales, nobody. What's it called? Recruiting, nobody. Payroll, nobody. Then we have accounting, all of them. Every other person, all of the other accounting, administration, executive, finance, human resources, IT, marketing, public relations, purchasing, sales, all of these now have what? Shipping and all of that. They now have what? They now have departments. Can you see? Those ones have departments. But these departments, about 15 of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16 departments, right? So we have 16 departments that does not have employees. Can you see? Right outer join um, department D, right? So that way, we are able to juxtapose two tables together to see which has more data than which. And that is what outer join does. That is what outer join does, right? So we want to restrict this statement now. We can say where department underscore name is what is null, right? If we run this again now, you see that it will only return all those who do not have what department name. I mean, sorry, why did I say department name? Where job ID is null, job underscore ID is null, not department name. Sorry, can you see? Where job ID is null, or can be first name is null. Can you see? So we have 16 of them, right? Where job ID is null, or when first name is null, when last name is null. So this department, all these departments does not have what employees. So basically, you've seen how to do a left outer and right outer join. Left outer and right outer join. Now, this is the full outer join that I was talking about, but there is nothing like that in MySQL. That's why it gave us an error here, right? If you run this now, it's going to give us an error because there's nothing like full outer join in MySQL. Are you following? Are you following? Now, the last kind of join that we want to talk about is the Cartesian product, right? Or a cross join. And what is a cross join? A cross join is usually considered a mistake, right? A cross join. A cross join is also called a Cartesian product. I'm sure. Let me see if I can spell that Cartesian. Okay, yeah, Cartesian product. A Cartesian product. Now, what does that mean? It means that I have employees table and I have the department table, right? Now, when you say cross join, we are saying that everything in this table, you are multiplying this table by this table, right? What that means is that if you have, let's say that we have 10 employees and we have 3 departments, 10 employees and 3 departments. What that means is that if you do a cross join or a Cartesian product of it, in each of these employees, what you would have is, let's say we have, let's say that the department that we have is, okay, let's just say, so as to be able to explain, let's say we have 5 employees, 3 departments, right? So we have department A, B, and C. We have Vivian, Lola, Fisher, IBK, and John as our employees, right? If we do a cross of this table, what you would have is that Vivian will be in department A, Vivian will be in department B, and Vivian will be in department C. Lola will be in department A, Lola in department B, and Lola in department C. Tricia in department A, Tricia in department B, Tricia in department C. IBK in department A, B, and C. So you have everybody in each of those departments. That is an error, right? And that is what we call a Cartesian product, right? And now, don't take it that it is an error. In some situations, you have some companies like that, right? You have some companies like that where a particular segment of the company or a particular set of people in the company are in all the departments, say teammates and all of that, right? So you can create a Cartesian product or a cross join in that kind of situation. So a cross join is where, so for our database now, for our database that we're using, right, for the database we're using presently, we have 107 employees, right? We have employees 107, and we have 22 departments, right? Now, if you look at it, how do we know what the product of a Cartesian product is? If we cross join it, that will be 5 multiplied by 3. That's this table, the 5 from here multiplied by the 3 here. So that's 5 multiplied by 3. So the total rows that you have is 15 rows. right? Instead of 5 rows that you have initially, right? Instead of 5 rows, because what you're supposed to have is Trisha is in Vivian is in department A, Lola is in department B, Trisha is in department B, IBK is in department A, and John is in department C. That's what you're supposed to have. But you now have each of them in all the departments. Therefore, it gives you what? 15 rows. So in this situation now, what you have is each person in the 22 rows. So that's in admin, you have 107. In sales, you have 107. In marketing, 107. So that'll be 107 multiplied by 22. Right? Let me see. What would that give us? 107 multiplied by 22. Anybody can help me? That's 2,354. 354 rows. Right? So usually this is what you will have as a Cartesian or cross-join result, right? So how do we write a cross-join? Say select first name, last name, job ID, department ID from employees cross-join department. Let me show you. If you run this, right? If you run this, can you see? It says 200 rows returned. 200 rows. Can you see? Look at Stephen King. Look at Stephen King. Stephen King is in AD Press. Is AD Press is in? Can you see? Is now in payroll. Is in recruiting. Is in what? Retail, government, blah 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 blah. Don't let me remove the limit from that. Hold on, just give me a minute. Right, can you see? The reason why it gave us 200 is because what's it called? The default limit for the system or for the rows returned is 200, right? So I just extended the limit. Let me extend the limit to 5,000, right? So that it can give us all the results, right? Also, so the total result of the cross product of the employees against all the departments is 2,889 rows, right? And if you look at it, you see that, look at it. Stephen King is in all the departments now, right? Nikocha is in all the departments. Bruce in Alexander Arnold. Everybody is all the departments. Does this look like a table, like a good table? Right. So basically, this is an example of a cross join. Right. This is an example of a cross join. So we try to avoid a cross join um, as much as possible. Right. We try to avoid a cross join as much as possible, unless it is needed. Unless it is needed. Right. So this has brought us to the end of joining today. This has brought us to the end of joining. We have done joining, right? Please let me know if you understood joining, even though we have lesser people in class today. A lot of people are busy, right? A lot of people are busy, but of course, they can always refer to the videos. So please let me know if you have any question. If you have any question, please let me know. We have 3 chapters to go. We have 3 chapters to go. We have 3 chapters to go. Tomorrow, we'll discuss 2, and that means we're wrapping up this training by next weekend. By next weekend, because we'll discuss 2 next tomorrow. Tomorrow, Saturday, and Sunday next weekend, we'll wrap up. I was supposed to bring the person that's going to talk to us this weekend, but he's not available this weekend. So hopefully by next weekend, I'll be able to bring our guest to talk to us. And also, finish up on Saturday. Then we use Sunday. We would be wrapping up this training. I think somebody will be excited, right? So if you have questions, please let me know. If you have questions, please let me know. We've done almost 2 hours, or even more than 2 hours of class today already. Yeah, we've done 2 hours of class today already. So if you have questions, please let me know. Please, I am waiting to hear from you. Any question? From inner join, where we talked about on and using clause, to hello, can you hear me? Hello, can you hear me? Network is
Yes, I can hear you.
all right.
I can hear you.
So any question so that we can wrap up today's class and finish tomorrow. We're doing 2 chapters tomorrow. We have just 3 chapters left. Finishing 2 chapters tomorrow. Subqueries and insert. Subqueries and insert. I think it's raining already, so network is beginning to mess up. Right? So, Lola, any question?
Nothing.
Awesome. Awesome. All right. We'll conclude both subqueries tomorrow. Subquery is very short, and insert updates how to populate a table. So all the tables that you have created, want to learn how to populate them tomorrow. This is also a very short topic, right? So in another 2 3 hours tomorrow, and if possible, if we can finish all the 3 chapters tomorrow, why not? And so that we can face what's it called? We'll face Git on Saturday. Git, I'm bringing a whole lot of students in for that class, a general class. I'm bringing the first. I didn't teach the. I didn't teach the first term. Or the first set Git, and also it's just a general class. A whole lot of people are going to be joining the class because I want to make it available to everyone. But of course, you guys are the owner of the class, so I wouldn't want you to miss that class, please. So, if possible, we are finishing. We're wrapping up SQL next tomorrow. I mean tomorrow. We're wrapping up SQL tomorrow, and we will use next weekend to talk to the person, our guests, and also to perform or to work on Git next weekend. So I'm really happy that we're at the end of the program. Also, during the week, our program coordinator will reach out to us to tell us about our project. You have to develop a project. You have to develop a project. You have to develop a project. And tomorrow I will be answering the question about how to um, use foreign keys, right? And that is after we've talked about chapter 11, which is inserting data, managing data with DML statements, right? Once we talk about that, then we can now begin to insert data. Once we insert data, then we can now begin to apply our alter table statement to include the foreign keys that we want to use. So I'll be talking about that tomorrow, and I'm going to be showing us that tomorrow. Yeah, tomorrow. Any question? Thank you for coming to class. It's been a beautiful ride, and yes, we are moving to the end. God bless you. I hope that you're practicing Please engage with the videos that we have. I'm going to download these videos and this video to this class and upload it immediately so that we can have access to it. And please engage with the videos. Please engage with the videos. Don't wait, right? The videos are always available. You can always engage with them. You can engage with them again, especially when you want to start working on your project. Assignments, please do the assignment and submit. They are to make us better, right? I want to see you use the skill, right? Um, and luckily for us, luckily for your group, um, I was supposed to have started my visualization training or the visualization training, but somewhere somehow we've not been able to start. So, but we're going to be starting very soon. I'm hoping that by maybe mid-November we can start so that we can run that through to December, so that at the end of December you're able to say that you've done this or you have this skill set, right? So if you're interested, I'll be sharing that with you. You can register for the training as well. It's going to be interesting. It's going to be mind-blowing, as we have seen in this SQL training. Also, I'll be sharing a feedback form with us during the week to be able to help us collect feedbacks from the training, what you think. We just want to know so that we can serve you better as we proceed and use the feedbacks to improve our servings to you, our offerings to you as well. So please, when you see the feedback forms, help me engage with them, help me fill them. It will make me and my company and everybody that works with me do better and perform better. Thank you for coming to class. I'm really grateful to you guys. God bless you. Do have a
Sorry,
peaceful.
sir.
Okay.
Please, for the assignment, the questions
Yes.
you answer in the assignment, can maybe can we ask questions on that? Maybe most later on, because there are some I'm still not quite
Yes.
sure
Yes. Yes.
on.
Yes. Do you want to ask the questions now?
Um, okay, like the third question, you said we should create a report of employees whose salary is from the in the range of $5, $500, and $12. Don't really know
Hold on. Let me.
to
I'm
do
trying to
that.
open the assignment. Just hold on.
Okay.
Create a report of a report of employees whose salary is not in the range of 5,000 to 12,000. So you don't understand it.
Yes, yes.
It's saying that create a report of employees whose salary is not in a range of 5,000 through 12,000, right? So basically, if you are saying the salary is in a range, is you are saying that the salary is between 5,000 but between 5,000 and 12,000, right? But if you are saying not in a range, then it means that the salary is not between 5,000 and 12,000. I've just answered that for you.
Okay.
Yeah.
All right.
Is that all?
Yes, for now, that's all. Yes, that's
All
all.
right. If you have more questions, you can ask on the group, actually. You can ask on the group so that people can
Okay. Okay.
benefit from it. And they can actually answer you from the group, not just me answering. It doesn't have to be me. Right. Guys on the group, Lola, Vivian, Anita, all of them. They are really good. They can answer your questions. And I'm sure that you also can
All
answer
right.
people's questions. Right?
Okay.
All right. So thank you for coming. Lola, I appreciate. Trisha, well done. God bless you. Enjoy your. Is it raining where you are?
Heavy.
Heavy. Wow. 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 All right. Enjoy the rainy